Hi friends, in continuation with the previous videos, today we are going to see the chiller plant details. What are the types of chillers, how we will find the chiller, how we will arrive the chiller capacity. We will go in detail. So let's start. Hi guys, in the previous video we have seen about the refrigeration cycle. So again I am capturing the same thing for deeper understanding. If you see from stage 1 to 4, there is a two color mentioned in that. One is blue with dotted, and red. So blue denotes the liquid and vapor form. Red denotes its full liquid form. That is how the refrigerant will keep changing inside the circuit. Depends upon the pressure and temperature, the property of the refrigerant will change. So what is refrigerant? What is the form of refrigerant? So as I said, the refrigerant property will change depends upon the temperature and pressure. Refrigerant is a substance used in a heat cycle to transfer the heat from one area and remove it to the other area. There are different types of refrigerants available in the market, so that is listed down: CFCs, CFCs, HFCs, and natural refrigerants. Okay, we'll see what are the types of chillers. See, there are three major type of chiller. In that, two types of chillers are widely used: water cooled chiller and air cooled chiller. Another one type, evaporative condensed chiller, very rarely used. So we will discuss in detail about water cooled chiller and air cooled chiller in this video. Now we will see water cooled chiller. The name water cooled chiller mean the mechanism of cooling the condenser through water. That's why it's called water cooled chiller. For this we need a dedicated cooling tower to cool the condenser. So it will be a separate unit. So the efficiency of the chiller will be always high because cooling tower is involved in this cooling process. So installation type will be always indoor. Chiller will be indoor and the cooling tower will be in the outdoor. So option generally it will be lesser compared to other type chiller, air cooled chiller. The space of chiller requirement also will be lesser compared to air cooled chiller, but initial investment will be more. The lifespan of this chiller will be more compared to air cooled chiller. So the range of chiller will start from 16 ton to 5500 tons. Depends upon the manufacturer, it will vary. So water cooled condenser type, there is a shell and coil, double tube type, and shell and tube type are available. So chiller classification as per compressor type, if you can define it: reciprocating chiller, centrifugal chiller, screw driven chiller, and absorption type chiller. So generally if you see, screw chiller will be most widely used in across so many commercial buildings. There are so many different refrigerant available in the market: R410A, R407C, R134A, R404A, R717. And similarly the maintenance of the chiller will be higher compared to air cooled chiller. So water and chemical usage will be more. So the coefficient of performance is the one always play a major role in selecting the chiller. So this, for water cooled, it will be 4.7 to 6. So weight of the chiller will be too heavy. But the another parameter which we need to know in the chiller is what is the leaving temperature and what is the entering temperature. So the delta difference should not be more than 7. So that should be the parameters we need to look into. So generally leaving temperature means the output from the chiller. On water cooled, if you see, it will be 4.5 degree to 5.5 degree centigrade. So similarly after the water enter into AHU, again the water will get into the chiller back as a input to chiller. So that temperature will be around 12 degree to 14 degree centigrade. If the insulation of the pipe, everything is good, then this range we will get in the actual measurement. Similarly, selection of chillers will depends on so many parameters like water source. Without water, proper water, then you can't go with water cooled chiller. Similarly, lifting and shifting and chiller performance, like what type of compressor they are using, what type of the condenser they are using, next pump performance, and what is the delta T, and what is the heat load. So depends upon so many parameters, they will select the type of chillers. And moreover, always once the chiller is finalized, the lead time will be always 10 to 12 weeks, because most of the material will be get imported, or so many imported materials will get involved in manufacturing. That is the reason the lead time will be more. So warranty generally they will give 12 months, and post that they will take the AMC. So that is how all the vendors, all the suppliers prefer. So there are so many manufacturers like Carrier, Train, Blue Star, Mitsubishi, Danam, Bosch, and York are available. Still more are there. Just I given only few names of the manufacturers. We will see air cooled chiller. So air cooled chiller, the cooling type is natural air. There is no external cooling mechanism provided for this type of chiller. So cooling tower is not required. So efficiency will be low compared to water cooled, because through air the heat has to be dissipated. So installation type will be always outdoor, and the power consumption will be more than the water cooled chiller. The space of the chiller will be more because the area they covered for making the more number of fins for the proper ventilation ventilation will be more. So initial investment will be very less and lifespan will be lesser compared to water cooled chiller. Range of chillers will start from 25 tons to 200 tons. So air cooled and air cooled condenser type, natural convection and forced convection type is available. So similarly chiller classification as per compressor type, reciprocating, centrifugal, screw driven and absorption type. Refrigerant used in the system is similar to water cooled chiller. In this maintenance will be very less. So water and chemical usage will be very less. And the COP, if you see, it will be 2.9 to 4.1. Whereas if you see in the water cooled chiller it will be more. So weight of the chiller it will be less compared to water cooled chiller. So leaving temperature here it will be 6.5 to 7.5 degrees centigrade. So again the leaving temperature will be higher than the water cooled chiller. The lesser the leaving temperature will be good. We will get more efficiency to achieve the temperature. So because the leaving temperature itself is 7.5, again the return temperature will be 13 to 14 degrees. So selection of chillers again depends upon lifting, shifting, chiller performance, pump performance. Delta T is nothing but the difference in the temperature. So again lead time same 10 to 12 weeks. So warranty the same. So manufacturers, if you see, Carrier, Train, Blue Star, the Number Shark, Mitsubishi, all are there players in the market. Cooling towers is having three types: cross flow, counter flow and hyperbolic. Types of fan used is propeller fan and centrifugal fans. Types of cooling tower construction will be mechanical draft towers and natural draft towers. So efficiency, mechanical draft tower will be more efficiency because of providing the fan to push the air faster. So capacity of the cooling tower will be also mentioned in tons of refrigeration, similar to chiller. Cooling tower materials, there are different types of material used: galvanized steel, fiber, glass, stainless steel, concrete. There are so many different types of material used. Materials are mentioned down. Need a maintenance for this. Here you are seeing the chiller pipe circuit. There is a unit called air handling unit is mentioned. You can see the chiller is mentioned, chilled water pump is mentioned, and condenser water pump is mentioned. And above if you see, cooling tower will be mentioned. So chilled water pump is needed for all the type of chillers, because that is the pump which will supply the water in the chilled circuit from chiller to AH room. So condenser water pump is needed only for the water cooled chiller. So chiller to AHU piping will be closed loop circuit. Chiller to cooling tower piping will be closed. It may open also. So type of pipe and insulation. So they will use of MS pipe. So it will be easy to do welding, and over that they will do proper insulation like glass fiber, foam, and over that they will do with the cladding to give a proper completion work or good finished look. That is the reason they will give the cladding above the insulation. So if you see this, you can able to understand clearly the circuit how it works. This is again the chiller pipe circuit in detail. If you see in chiller, there will be two parallel pipes running into the chiller. Water from cooling tower will not go to the AH room. So there is a two different circuit. Inside the chiller, only the heat exchange will happen. Heat from the space where we need air conditioning will be absorbed by the chilled water, and that will come to a chiller. From chiller, that heat will be transferred to the other circuit, which there is a circulation of water happening from cooling tower to the chiller. So chiller will act like heat exchanger of absorbing the heat from one place, and it will be taken to chiller. From chiller it will be get transferred to the other circuit, and that heat will be emitted in the atmosphere through the cooling tower. So I hope this circuit will give a clear understanding about how the chiller works. Thank you guys. Hope you like the video about the HVAC chiller system. Please like and do subscribe. I will start sharing about other topics in the upcoming videos. Thank you so much.